Hello everyone, myself Dr. Indra, Assistant Professor, Department of Mathematics, SRM Madurai College for Engineering and Technology. In this video, I am going to talk about characteristic equation of matrix. The characteristic equation is associated with square matrix. For example, we consider a square matrix A in n by n dimension if we have A minus lambda I with I is an identity matrix of the same order of that of A. This matrix A minus lambda I is the characteristic matrix. The equation determinant of A minus lambda I equal to 0 is known as characteristic equation. The value of lambda is called characteristic roots, and it also got some other names like eigenvalue and also known as latent value. Let me just explain an example how we calculate the characteristic equation. Given a familiar 3 cross 3 matrix A as 1, 1, 1 in first row, 1, 1, 1 in second row and 1, 1, 1 in third row also. Then its characteristic matrix can be obtained by A minus lambda I, where lambda is a scalar and I is the identity matrix of the same order of the matrix A. So, let me explain how to find a characteristic equation of the given problem. We have the matrix A minus lambda I. A is nothing but the given I matrix. Lambda is a scalar. I is the identity matrix of the order of that of A. Just substituting the values in A minus lambda I, we get 1 minus lambda 1, 1, 1, 1 minus lambda 1. In third row, 1, 1, 1 minus lambda. Now, this will be the characteristic matrix of the given matrix A. We can simply observe the characteristic matrix can be easily obtained by just subtracting lambda from all the diagonal elements of the matrix and keeping the other values as it is. So you can see in diagonal we can write 1 minus lambda, 1 minus lambda and 1 minus lambda. The remaining values we can write as it is. Next, we have to find the characteristic equation. We can expand this with first row. So, we get 1 minus lambda. So, strike out the corresponding row and corresponding column. We have 1 minus lambda into 1 minus lambda. So, it gives 1 minus lambda square minus 1 into 1. We get minus 1. Next, second term we have to put in negative. So, minus 1. In first row, we have second value 1. So, we have to write minus 1 into strike out the first row and the second column. We get 1 into 1 minus lambda minus 1 into 1. So, we get minus 1. Next, third value plus 1. In first row, third value is 1. So, plus 1. So, you should not consider the first row and third column. We get 1, 1 minus lambda, 1, 1. So, multiply the cross values 1 into 1. We get 1 minus 1 minus lambda. So, we have to write it in the opposite sign. So, minus 1 plus 1. After expanding all the values, we just write the values like minus lambda cube plus 3 lambda square, because the coefficient of lambda and the constant term will be 0. So finally we got the characteristic polynomial as minus lambda cube plus 3 lambda square. So the characteristic polynomial for this problem is minus lambda cube plus 3 lambda square. From this, we can write the characteristic equation. So the characteristic equation is nothing but minus lambda cube plus 3 lambda square is equal to 0. So this is the characteristic equation of this problem. In 3 cross 3 matrix, we have the first coefficient as lambda cube. Thank you.